Hello, everyone, and welcome to the second part of degrees and radians. Well, so far, we've learned that we can measure degrees by the use of Cartesian plane. In fact, this could be used as our general guide to solve real-life applications. All right? So right now, what we're going to do is we're going to have a continuation. So if you want some, forgive me, if you want some background information, or rather you want to recall some information, I suggest you should just watch the previous video, right? So anyways, let's proceed. So now, in this video, we're just going to add some additional information about degrees, all right? So remember the three types of angles that we used to learn in our high school days. First is we have acute angles. So how will you know if the angle is acute? Well, if it's acute, then we can further conclude that the angle given should be greater than 0 degrees, but less than 90 degrees. So not exactly 0 degrees, not exactly 90 degrees, but in between them two. All right? And if you're going to recall that this is where 0 degrees located, 90 degrees located, 180 degrees, 270 degrees, and here we have 360 degrees, right? So if you're going to form an angle, starting from here until here, which is actually between 0 degree to 19 degrees, expect that you will form an acute angle, all right? So anything or any angle that is formed within the first quadrant, not exactly 0 degrees or 90 degrees, then you will form an acute angle. What if, let's just say, the angle reaches to 90 degrees exactly? Then you will have a right angle. So right angle is basically an angle that is 90 degrees. So starting from here, going there, you will form a right angle. So if you're going to form a right angle, expect that there will be a shape located between the two sides, which is this one, all right? If you ever encounter this shape, a square-like shape thingy, it implies that the angle formed in the vertex, or the angle formed between the terminal side and initial side, is 90 degrees. Now, what if the angle goes beyond 90 degrees? So that would be just obtuse angles, all right? So if it goes more than 90 degrees, but less than 180 degrees, you will form an obtuse angle. So for example, you start from here, going there, you will form exactly, forgive me. You will either form greater than 90-degree angle, but less than 180 degree. So for example, let's just say this is 145 degrees. All right. So the same thing on how would you find acute angles, right angle, and obtuse angle when it is rotated in clockwise. Remember that in clockwise, we have a different set of angle, right? So we have 0 degree, negative 90 degree, negative 180 degree, and we have negative 270 degree. Oh yeah, I forgot. We have negative 360 degree. So the same thing, all right? Like you start from here, then you form an angle on the fourth quadrant, and it's rotated in a clockwise direction. You will form an acute angle, all right? The thing is, wait a minute, it's negative, right? Yeah, it seems negative, but it's still an acute angle, all right? So assumingly that this is just positive 90 degree, all right? Let's get the absolute value of this one. You will have positive 90 degrees, all right? And then if it's exactly at 90 degrees, well, you will have a right angle. All right, but it's still negative. Still, what do you call this one? You can make it into positive, because the thing is, when it comes to acute angles, right angles, obtuse angles, it doesn't matter what sign, right? Doesn't matter what sign you will form. What matters is what number or the angle will form. All right. So in other words, in the finding the acute angles, right angle, obtuse angles, it doesn't matter the sign. Okay, it doesn't matter what will be the sign given to a given angle. It doesn't matter. What matters is the number. So just like this one, if your angle forms at 90 degrees, but it is rotated at clockwise rotation, it is still considered as right angle. But we will disregard the negative sign. And the same implication as well if you're going to have an obtuse angles. All right. So that's basically it. All right. Now, another last information we need to know about degrees is the application of complementary angles, which basically means all angles sum up to 90 degrees. And we have supplementary angles, that angles sum up to 180 degrees. All right. So how would we know if the given angles sum up to 90 degrees or they sum up to 180 degrees? How are we going to know that? Oh, wait, forgive me. What I'm trying to imply here is that how are we going to know if they are complementary angles or supplementary angles? Much better. All right. So let me give you an example. Let's just say we have 30 degrees and 60 degrees. All right. Now add them. So if I'm going to add 30 degrees and 60 degrees, we will have 90 degrees. So since the sum of 30 degrees and 60 degrees is 90 degrees, therefore we can conclude that these two are complementary angles, because these two angles sum up to 90 degrees. Now here's the question. Is the sum of 30 degrees, oh wait, forgive me. Uh, are these angles, 30 degrees and 60 degrees, are supplementary? Are they supplementary? The answer is no. Why? Because according here, if you're going to add them, it's 90 degrees. So it does not sum up to 180 degrees. Therefore, it is not supplementary angles. All right? Let me give you another example. Let's just say you have 60 degrees plus 60 degrees plus 60 degrees, right? If you're going to add these three, what would be the result? So 60 degrees, 60 degrees, and 60 degrees. Wait, 60 degrees. Wait. Let me just fix my handwriting. All right, let's go. 60 degrees. This will result to 180 degrees. So, does that imply that these given angles are supplementary? The answer is yes, because these angles are, these angles, when you're going to sum them up, the answer is 180 degrees. So these are, in fact, supplementary angles. All right? So in here, it doesn't matter what angles or given angles you have. It doesn't matter if it's 1 degrees or it has decimal value like 49.5 degrees. It doesn't matter actually. What matters is the result. If two angles sum up to 90 degrees, then that would be complementary angles. But if they sum up to 180 degrees, then they are just supplementary. All right? So I hope you get the idea. Again, it doesn't matter what would be the exact or given angles for you to know if it's complementary or supplementary. All right? All it matters is the result itself. So again, if you add up all the given angles and the answer is 90 degrees, then they are complementary. But if it sum up to 180 degrees, then they are supplementary. All right? So that is all for the degrees. Now we can proceed to the radians. So radians, this is basically another way to measure angles. The unit is just basically rad. All right? So how can we form angles with the use of radians? So let's talk about its background. All right. The radian is actually from the circle itself. So suppose we have a blue circle, and remember that in every circle, there's always the center, the midpoint, the center point. And of course, there is what we call as the radius. All right. Radius is basically the chord or a line segment that shows the distance between the center and an endpoint. So for example, we have a radius here, right? That's it. This is a radius, all right? So let's go back to what I'm trying to imply. Suppose we have a central angle, all right? So this is the central angle, all right? Central angle is formed because of the two radius, right? Two radii, sorry, two radii, right? These line segments here, or yeah, basically a chord between the center and an endpoint is what you call as the radius, right? So these are radii. Radii is just a plural word for radius, all right? So anyways, so we have a central angle. By the way, when you say central angle, angle form at the center of the circle, right? So yep, this is the radius and this is the radius. Now, in this part, let me just thicken this particular arc, right? This thickened part here, this is your arc. Let S be represented as arc, all right? The thing is, when we say arc, it's just basically the curve of the circle, all right? Let me draw this one. Assume that this is a circle. When we say arc, it's just basically the circumference, meaning the whole curve, the whole curve, all right? But here's the question though. If arc is like circumference, meaning the whole curve of the circle, then why is that we have a curve here that is not even a whole, rather it's like a part of it? Well, it's because to avoid complications, all right? Let me give you another circle. You see this circle? Now, suppose we have a central angle. This one, yeah, we have a central angle here, all right? So in here, we have two arcs already. One is the intersection of the central angle to a particular arc, which is this one, the red one. And we have the rest of the arcs that are not being intercepted by the central angle, which is this one. So this blue, it is still an arc, but we call it as the major arc. All right? We still call it as a major arc. As for the red, we'll call it as the minor arc. All right. So now, the thing is, it's confusing because both of them are arc, but different. Like this one, for the major arc, it's the rest of the curve that are not being intercepted by the central angle. Then we have the red one, which is the arc that is intercepted by the central angle. So this one, this thickened part of the arc here is the minor arc. All right. But to avoid confusion, we would rather just simply describe it as arc, much better. Because if you're going to pertain to the whole curve, that's already a circumference. All right. So bottom line, it's up to you if you're going to name this as a minor arc, which for me, I highly suggested to do so. But for now, we're going to discuss more likely about circles in this subtopic. All right. What we're going to discuss here is the relationship between arc and the radius in forming radian. All right. So you can just say this is an arc or minor arc. It's up to you. Right. Anyways, let's now proceed. Okay. So we have a given arc or minor arc here. All right. So now, how to get this angle? This one. How can I get the angle here? So obviously you can use by degrees. All right, you can. In fact, if you're going to uh, rotate this line in one hole, you'll form 360 degrees, right? So when you do that, one whole rotation, you will form exactly a circle, right? You will form a circle immediately if you're going to rotate it into 360 degrees, right? But yeah, degrees aside, how about in radians? All right, how about in radians? So in radians, all you need to do is to get the ratio of the arc and the radius of a circle. Or in other words, arc length or S divided by the radius, which is basically like this, or in simplified, it's like this. All right? Because if you're going to get the answer for this one, you will have the unit rad immediately. Why is it rad though? All right? Suppose this is 3 meters, right? And the radius here, let's just say this is 1 meters exactly. So to get the radian, it's simple, all right? Theta is equal to 3 meters divided by 1 meter. The answer for that is 3. And as you can see, there's no units because they have the same units from above and below. So the meters are cancelled. So to avoid confusion, we're going to label the unit as rad or radians. All right. So that is why the unit here is radian. Okay. Now, how are we going to form an angle with the use of radians? So let me give an example. Remember that in a whole rotation, you will form 360 degrees, right? One whole rotation is 360 degrees. Okay. And I said earlier that one whole rotation, you will exactly form a circle. So that means, assuming me that this is the center, this is the initial side, then the terminal side will start from the initial going up to the initial side again. So it's one whole rotation. So one whole rotation, you will form 360 degrees. So how are you going to uh, interpret this one in radians? All right. So since we are talking about arc length and radius, assume that the initial side is the radius. All right. That the side here, the white line, is the radius, especially the terminal side. The terminal side and initial side are radius. Just imagine. Then it rotates 360 degrees. So that means it covers up the whole curve of the circle, right? It covers the whole curve of the circle. So now that means this is the whole arc, all right? This is the whole arc. Remember, radians exist because of the intersection of central angle and the arc itself. But as you can see, the central angle here is 360 degrees. That means it intersects the whole curve. So meaning the whole circumference of the circle. Remember that the circumference of the circle is 2 pi times the radian times the radius. So we can say that this is also your arc length. All right. Remember, arc length is just as the circumference of the circle. All right. But it will be implied in different way. All right. Because if the central angle is 360 degrees, then the arc length is the circumference. But if it's not 360 degrees, then it would be a different scenario. I'll explain later. Okay, so suppose you have this the S as your central angle. No, sorry. What's that again? Yeah, arc length, right? Then you have 2 pi times r. Now divided both sides by r. So you will have S all over r is equal to 2 pi. Remember that S all over r is equal to theta. Therefore, we will substitute S all over r by theta. So you have an angle of 2 pi. But since we're now referring to angle, don't forget to have radians. So what can we say? We can say that 360 degrees is just the same as 2 pi radians. All right? 2 pi radians. Now, how about this one? All right, how about this one? Let me just erase this. Right? Okay, how about this? What if you form an angle of, let's just say, let's just say 270 degrees, all right? And you want to know its radians. So you start from here, going there, right? So you form 270 degrees. So that means, okay, in circular motion, you start from here, going up to here, exactly, right? Here. So the whole curve intercepted is from here up to here. Wait, there you go. That's it. All right, that's it. So now, what would be the S here, or your arc length? Remember what I said, that the arc length is just like the circumference. If and only if it formed 360 degrees. But no, it formed 270 degrees. So what would be the arc length? So as you can see here, this is a whole circle. And 1/4 is removed. All right, 1/4 is removed. Therefore, the arc length here is 3/4. Wait, 3/4 times, wait, forgive me, wait, there you go, okay. Anyways, so that means the arc length here is 3/4 of the circumference of the circle, or 3/4 times quantity 2 pi times the radius. Okay, why is it 3/4? Well, imagine that you have a circle or a pie, all right? If this one is shaded, that means it is one shaded out of 4 parts. But if there are 2 shaded, that means there are 2 out of 4 parts that are shaded. Now, if it's 3 are shaded, then that means there are 3 out of 4 parts that are shaded. All right. And if it's if all the parts are shaded, then that means 4 out of 4 are shaded. All right. So the same thing we can imply here is that since this is 3/4, so we're going to use this one in here. So we're going to get the arc length by having 3/4 of the 3/4 of the circumference. So here we will simplify. So this 2 will become 1 and 4 will become 2. We will have 3/2 of pi r. All right. Now, similarly, we will divide both sides by r. So we will have S all over r is equal to 3/2 pi. And again, theta is equal to S all over r. Therefore, you will have theta is equal to 3/2 of pi radians. So that means 270 degrees is just the same as 3/2 pi of 3/2 of pi radians. So that's how we form radians. So it has an application of circumference for you to get the arc length. Then after that, just divide both sides by the radius or r, then substitute s all over r by theta, and you will get the radians. All right. So let's try one more example. All right. How about if you form 180 degrees? So if you form 180 degrees, you will actually form a straight line. All right. So for example, here, all right, starting from here, going there, you will form a 180 degrees. So the only things that cover up are basically half of the circle. So that means it is actually one half of the circumference, all right, or 2 all over 4. 2 all over 4 is just the same as one half. So we have S is equals to one half of the circumference, which is 2 pi times r. So cancel the 2's. We will have 1 times pi r. So what we have here is we will have S is equal to pi times r. Now divide both sides by r. We will have SR is equal to pi. And remember, S all over R is theta, so we have theta is equal to pi. Then put radians. So that means this is just the same as 180 degrees. So for you to form 180 degrees, the radians must be pi radians. That's it. So that's how you form radians. So how can we find some other extra information about this one? Or in other words, is there another information about radians? Well, there's one though. So remember that we have 1 degree is equal to 1 out of 360 of a complete rotation, right? Do you guys remember that? So how about for the radians? So for radians, you will have exactly 1 radian is equal to S all over R, where S is equal to R. So what does that mean? It means that we will have exactly 1 radian when the arc length and radius of a circle are equal to each other. Right? So for example, you have a given central angle here, right? Then you have a radius of 2 meters. Then the arc length here is also 2 meters. So if you're going to get the angle here, so 2 meters, which is your S, divided by 2 meters, which is the radius, so you have 1 radian exactly. All right, so for you to form 1 radian, make sure that the measurement of arc length and the radius are the same. All right, so with that, let's try to have some break. All right, so let's just have some short break, then we cannot proceed to the other information needed to discuss. So take a break for like 5 minutes. All right. By the way, forgive me if you hear like recording in progress. I'm using actually Zoom application to record this discussion. All right. So what do we know so far? Overall, we know that degrees and radians are the two measurements of angles, right? And in addition, they are related to each other. All right. You already know why they are related because earlier we know that 360 degrees is just equal to 2 pi radians, right? So that's it. Now, due to this, we can convert a certain angle in degrees into radians or vice versa. Meaning we can actually convert an angle with a degrees into radians or radians into degrees. We can do that. All right. Now the question is how. So first, let's start with degrees to radians. You want to convert a given angle that is in degrees, then make it to a radian. So how though? So we have 360 degrees, right? Is equal to 2 pi radians. Okay. what we're going to do here is that we will divide both sides by 360 degrees. So the result here is we will have 1 degree is equal to pi all over 180 degrees radians. All right. So how come that I got pi all over 180 degrees? We have 2 pi all over 360 degrees once we divide 2 pi by 360. But since these two are both divisible by 2, so we can cancel them out. This 2 will become 1, and this 360 will become 180 degrees. Right? So therefore, we have 1 degree is equal to pi all over 180 degree radian. So if you want to convert a degree to radian, use this. All right? Then how about if we're referring to radian to degrees? So for this one, okay, 360 degrees is equal to 2 pi radian. Now, we're going to divide both sides by 2 pi. All right? So the result here is we will have 180 degrees all over pi. Wait, let me just fix the pi symbol. All right. So we have 180 degrees is equal to 180 degrees all over pi is equal to 1 radian. All right. So in 1 radian, you have 180 degrees all over pi. So you're going to use this one if you want to convert a radian to a degree. But if you want to convert a degree to radian, you're going to use this one. So let me give you one example only. Don't worry, the next video we're going to have some short practices or some examples. Suppose we have 90 degrees and you want to convert it to radians. So how are you going to do it? So remember, 1 degree is equal to pi all over 180 degrees radian. So that means you will multiply 90 degree by 1 all over 180 degrees. Wait, I forgot this is pi, right? Pi all over 180 degrees radian, right? Don't forget this one. So because of that, we can get the answer. So 90 degree times this would be canceled because 90 degree and 180 degrees, they are actually divisible by 90 degrees. So we can simplify. So 90 degrees will become 1, 180 degrees will become 2. So hence you have 1 times pi all over 2 radian. Hence, your final answer is pi all over 2 radian. See? That's it. All right? That's how you get the radians. All right? So one more example. Let's just say we have 100 degrees is equal 100 degrees only, forgive me. Now let's convert 100 degrees to radian. So this one would be 100 degrees times pi all over 180 degrees radian. So this, we can simplify this to 100, what's this? 100 degrees and 180, they're actually both divisible by 20, all right? This is actually 50 degrees. This is actually in 90 degrees. And we can simplify this one further because 50 and 90 are both divisible by 10. So we can have 5 degrees and we can have 9 degrees. Hence, you have 5 degrees times pi all over 9 degrees radian. So hence, you have 5 pi all over 9 radian. So that means 100 degrees is 5 pi all over 9 radian. All right? Now, what if you want to convert radians to degrees? So we have pi all over 2, right? Earlier. Pi all over 2 is just the same as 90 degrees. So let's prove it. Recall that if you're going to convert radian to degree, you're going to use this one. So that means we will multiply the given radian by 180 degrees all over pi. So here we can cancel pi on both sides. We will have 1, 1. Then here, 2 and 180 degrees, we can simplify them because both of them are divisible by 2. So we will have 1 and we will have 90 degrees. All right, 90 degrees. Therefore, we will have 1 all over 1 times 90 degrees all over 1. Hence, you have 90 degrees. See? All right. Now, next, what if we try to prove that 5 pi all over 9 is just the same as 100 degrees, right? 100 degrees is 5 pi all over 9. Now, let's prove it here. So with this, we're just going to, wait, forgive me. We're just going to multiply this one by 180 degrees all over pi. So first, we can cancel the pi's here. So we will have times 1, and here we will have 1. Then here, 9 here, and 180 degrees, we can simplify that because 9 and 180 are both divisible by 9. So this one will become 1, and this 180 degrees will become 20 degrees because 20 degrees times 9 is 180 degrees. Therefore, you have 5 times 1 all over 1 times 20 degrees all over 1. So multiply them together, you will have exactly 100 degrees. Therefore, it is proven. So that is how you guys convert degrees to radians and radians to degrees. So I think that is all, guys. All right. So take a break for a short moment, then you can proceed to the next video. All right. So that is all. But don't worry, guys. We will have some short examples for uh, for this type of problems, like conversion, degrees to radians, and radians to degrees. So that is all, guys. See you soon.